Good morning and welcome to our 20th annual exhibit of hydrogen and fuel cell technologies. We've added batteries this year, so we cover a whole gamut of products and product developments. Of course, fuel cell industries depend upon other people coming from other fields who add to the technology mix. One of the examples would be the infrastructure surrounding typical fuel cell technology. It requires all sorts of specialist technologies that come from other companies outside the fuel cell industry who help us to achieve a better product. One of these experts is Robin Powell. He's technology manager at Westwind Air Bearing, and we'll be talking with Robin Powell about air bearings, precision, speed, and cleanliness. Please welcome with me Robin Powell. Good morning.
Good morning.
Robin, Westwind Air Bearing, not everyone here will know, of course. Could you describe a bit about the company history, where it started, where it's located, and what you people do?
Sure. Westwind Air Bearing is located on the south coast of England. And Westwind were actually the first company to offer air bearing spindles as a commercial product. And we've been doing that now for well over 50 years. We developed into several markets over the years. Primarily electronics, semiconductor, and industrial applications involving accuracy, speed of operation, and areas where cleanliness is of particular importance.
And of course, we'll have to return to the subject of cleanliness. As we were preparing for this talk, you mentioned that most people who have digital technology have something that's been done by your company. Where does Westwind Air Bearing perform a service there? Is it the drilling that...
Our largest single market is the drilling of printed circuit boards.
Okay.
And we have a market share large enough in that market. It's sure that everybody has a product with a circuit board within it, drilled with one of our products.
And there the issue is simply that if you drill a hole in such a small space, it's got to be exactly where it should be.
Well, current electronics, the holes are only 100 microns in diameter. So in order to drill those, you need to spin a drill at over 200,000 RPM. And there are so many holes, you have to drill them at 6 or 8 or more times per second. So productivity, accuracy, long life, and reliable operation are key to that industry. And we've been doing that now for a long time.
Okay, you mentioned the history, 50 years of experience. What's the longest running device that you have?
We know of a whole factory equipped with our products actually making surgical instruments, surgical sharps, which have been in continuous operation for over 40 years. And they show no signs of wearing out.
Okay, 40 years of non-stop operation. So basically you can buy this as a child and retire with it.
Pretty much.
Pretty much, okay. For those of you who don't understand the technology, and there's some nifty sides to this, what exactly is an air-bearing device?
On the air bearing, the short form of what we'd call it is a gas lubricated bearing, as any gas will do. But it involves in supporting the rotating shaft reference to a static bearing by establishing a gas film between the two. And by managing the pressures within that gas film relative to the motion of the shaft against the bearing, we can maintain the axis of the shaft very accurately within that gas film. The gas film provides both the lubrication and the damping and support for the moving part.
I found this interesting when we were discussing this for preparation for the interview. Of course, bearings in bicycle wheels, you can actually see them. And, you know, those round little balls between two metal surfaces, they're mounted usually in some sort of convex shape, and the wheel spins. The air bearings, they're the bearings, it's just a metaphor, isn't it, for what they do? I mean...
the closest parallel, if you like, would be the gas molecules, which are actually in the film. Okay. The number of times of the impact on either side. It's a pressure distribution field. and by careful management of the clearances and the geometries, we can arrange for those pressures to move to oppose the motion or the load that's being applied to the shafts.
Okay, so if I interpret this, we've already discussed the long lifespan of the device. This lowers friction.
The friction is very low. In fact, it's almost entirely due to the viscous shear of the gases involved. Different gases, of course, have different characteristics, but gases are the lowest form of fluid loss that we can have in any bearing system.
So this would spin off into two benefits. One would be if you have to do something high speed drilling. I'm sure there's other things that need high speed. You would have no issues of lifespan. Lifespan is usually probably the number of revolutions per lifespan here. So the high speed would be possible. What about energy consumption?
Energy consumption is very low. And while we have certain design parameters where we can alter it to a certain degree, if you're comparing them with the rolling element bearings like your bicycle wheel, it's fairly close to zero.
Okay. So this would also mean, I suppose, it doesn't generate as much heat due to the friction of the entire unit.
That's true. The losses are far smaller.
Okay. I'm spinning around all the dimensions besides lower friction, lower energy consumption. What about size?
The size of the bearing may well be larger than a ball bearing unit that you put in. However, in terms of the system, for example, on a blower, the ability to run at the much higher speeds without fear of compromise in terms of life or energy consumption would mean that you could use a much smaller impeller on such a blower, and the overall device would be much smaller in size, helping a footprint.
Okay, this would be, of course, for some applications entirely crucial, that you get more blower per square centimeter, I suppose. I don't know how to express that in terms of a physicist, but more blower per square centimeter, a smaller footprint for the same function.
Certainly with mobile applications where space is at a premium.
Okay. Now, you describe this as an air bearings. We have this word air here. Air, of course, is a mixture. So does it work with various gases? Is it choosy about the gases it works with?
Usually you choose it's a question of operating with the gases which are available in the system we're talking about. We have in the past, for example, made air bearing systems that work in fluorine gas. Not particularly pleasant to work with, but in the environment that we had, we could run the bearing system on fluorine gas and avoid any contamination that would come from running a bearing system on any other material.
Okay, so wide range of gases. Let's look briefly at this device here that you've got with us. Could you describe what exactly this, what this device does?
Well, this would be a representative blower that we built against a basic specification to see what we could actually do. So this is scaled around the requirements of a 1 kilowatt fuel cell combined heat and power unit, and this is made to operate at around 70,000 RPM and deliver about 10 grams per second at about a 200 millibar overpressure. So fairly typical numbers that we chose as being something worth representing. All of the components are eminently scalable, both up and down, to suit any particular requirement that we may find somebody is in need of.
Okay, so you can do small and large.
We can do small and large.
Now, when we look at the potential for this technology in the fuel cell industry, it seems to me the first thing that comes to mind is the particular fussiness of the PEM technology. It does have certain operating parameters, and it's very, very skeptical when other gases pollutants get into the machine. So how does this technology work well with the PEM cell?
There is no other lubricant in the system. The air that you're feeding the PEM cell with is the lubricant which is going around the bearing inside of the system. So there is no other there is no contaminant in the system to get to the PEM cell.
This would be, of course, very vital if you have a PEM cell with the platinum and all other sorts of things. It's pretty easy to throw a wrench in the works there. We usually talk about sulfur and CO poisoning, but of course, lubricants and other things are an issue here. So this is ideally adapted to the PEM cell.
And it is. Another aspect with the PEM cell, of course, with its variable duty cycle, is the start-stop cycling. This particular type of air bearing is an aerodynamic air bearing, which means that should you stop it, there are surfaces in contact. However, the processes that we've developed to support that have been tested beyond 500,000 start-stop cycles without a degradation in the rotational performance. So it's ideally suited for the kind of duty cycles that a PEM cell runs through.
500,000 stop-start. I hope you automated this. There was no poor engineer with a switch.
This was automated and it ran day and night. In fact, 500,000 cycles wasn't the limit. We just got bored.
You got bored, yeah. Okay. This is the same thing in a lifespan. You can buy this when you're a kid and it'll outlast you. Okay, so 500,000. Now the start-stop cycle, of course, we have two technologies here, and I generally hear the story that the PEM is good for, or better adapted to start-stop. The solid oxide fuel cells, I've only seen one exception where they can deal basically the damage that gets done to the system in the solid oxide fuel cell, the potential damage, is when they're starting and stopping. They like to run and keep running, and they don't like to be turned on and off. So what about continuous operation?
Well, continuous operation, there is no wear occurring. And so the lifespan, we almost don't have anything to subtract from the running. A rolling element bearing tends to come with a nice, clearly defined lifespan, which is impressive for the devices that they are. But we can't put a sign to that because in continuous operation, there's no wear occurring. They will just carry on.
They'll just carry on. I suppose one question everyone likes to ask is, what does this cost? If we compare this to conventional blowers, would this be slightly more expensive per unit?
An air bearing system is very rarely going to be the low-cost option. It's a solution that would be taken when in pursuit of the highest efficiencies and the longest lifespan. And in our experience, that's where it rapidly pays for the extra investment in the system cost up front.
So if we take the example of a solid oxide fuel cell system that is offering a kilowatt of energy, there's going to be some savings once you install such a blower that actually means there's going to be a payback down the road?
Well, there's room with an air bearing system to more closely approach the ideal conditions in terms of running the impeller at a higher speed to get a better overall efficiency on the impeller itself without losing the power in the bearings or in the bearing life. Also, the accuracy of rotation means that impeller tip clearances can be kept to a minimum and benefit from the efficiency on that side of the system. And the reduced power consumption of the device overall. This all helps to reduce the parasitic loss that the blower represents. And the current budget for the parasitic losses, it's quite high.
So this is, of course, this is one of the reasons why we should come and visit your booth, because precisely that equation, depending on the size of the system, can be a game changer. We all want to have a PEM cell or a solid oxide fuel cell that offers efficiencies that make this the most viable technology, whatever we're running. It could be, using natural gas, it could be using hydrogen, but those efficiency statistics are incredibly important. So this is one of those equations where the parasitic loss can make a difference of, do you have a ballpark figure, perhaps as much as 5% or?
5 or perhaps even 10%.
Okay, so a 10% increase in efficiency is a very significant thing within the whole equation of how efficient the fuel cells are. Whenever we talk with people who are involved or interested in this industry, but they come from other fields, I mean, you have a business model. The fuel cell industry is not the big market. You mentioned the computer chip manufacturing, there's the medical and so on. So you have all sorts of products. But people who offer to larger markets, they don't often want to get involved with the problem the nice engineers here are involved with, which is sitting down, number crunching, and then going to some manufacturer and say, can you help us create a perfect bipolar plate? But it's got to be this size and not the size you offer. Have you got any gaskets? Can you do any, molding for us, but something different? So do you offer a catalog service, or do you actually take the time to sit down with the engineers and look at their drawings and figure out what they need optimally to make that thing work?
Well, it's an odd thing. We've made catalogs from time to time, but we always end up making custom products. Our business has worked very well by going through in detail with people what they actually need to make a full advantage of what we can offer and to, as closely as possible, approach the ideal solution. And certainly in the fuel cell industry, we've seen that every marker of efficiency that we can gain is worth some pursuit. So we welcome the approach of people with quite specific applications so that we can avoid any compromise that might come in by trying to use a catalog item that doesn't quite fit.
This would be, of course, this is a very important message. The fuel cell industry is still examining niche markets, producing products that are right now commercially successful, but looking for the larger markets. So every year, it seems to me, there's been changes. There is no standard size fuel cell. There are many options available, and it's incredibly important for the industry that they can work with people, systems integrators, can go to you and other people and ask for specific characteristics for that infrastructure. So this is sort of part of the business that you do. I like your job title, technology manager. This does not mean that you basically manage an existing off-the-shelf technology. You get involved in technology development by doing so. Am I hitting the mark?
Oh, absolutely. And luckily, the fuel cell blower market is one that seems to ideally sit with a set of technologies that we have developed. So we can approach this with a high level of confidence with the performance and lifespan for the sorts of products that we're offering. We have a good overview of the various different types of air bearings, of which there are, of course, more than one, and we have a good experience with them and believe we can select the right types.
Well, this has been a fascinating, for me, very informative talk. I think the important messages I've gotten from this is the reduction in size can be important if it's a mobile application. The zero impurity issue there, it's not going to introduce any lubricants into the system, more energy efficiency, and then lifespan, that's a zero issue. with this technology. So this sounds like an optimal mix, something we absolutely need in the fuel cell industry. Have you been enjoying the fair so far, and has it been going well?
Oh, it's a wonderful fair. It's the first time that I've attended these, and there's a lot of fascinating subjects. It's a shame we don't have time to go and learn about all of them.
Yeah. Well, I hope the fuel cell industry gets the message here. I think it's a really interesting technology to look into, and certainly one which could help the efficiency equation, among other things, break that barrier. Just a little bit more efficiency can make play a decisive role in whether this technology takes off. So I have been talking to Robin Powell, Technology Manager at Westwind Air Bearing. It's been a pleasure talking to you. I hope you come back next year, and I hope you enjoy the fair.
Thank you very much.
Thank you, Robin. And thank you. I should mention, if there are any questions here, the real details, as we found out in the discussion, the real details, they're available at the booth. There's so many fine parameters to get into. E67/1, in that direction there. Visit Robin Powell, and he'll be looking forward to your questions and what he can do for the industry. Thank you, Robin.